Hi, my name is Gagan Bansal and welcome to my Whiteboard talk. Today I'll be talking about building a new environment for studying agentic markets. Think about a marketplace like eBay where the buyers and sellers are AI agents that are acting on behalf of people. So here are buyers and sellers in the marketplace, and there are AI agents that are acting on behalf of each of these. Now, think about what happens in this case if these AI agents start to make important economic decisions in this setting. Making these economic decisions is an important responsibility. There are many ways it can go wrong and can have real consequences for users. And there are many reasons this setting is actually quite complex. One of them is that there are many parties involved here. There are so many buyers, so many sellers, and there are agents representing all of them, and there's a marketplace, and each of them can have different competing objectives. Another reason this setting is complex is because these agents are probably powered by LLMs that we don't fully understand. We don't understand the reasoning processes. We know they're stochastic. We don't understand what the underlying neural networks are doing. And third, these agents themselves could be acting at superhuman speeds. They can also be learning and adapting over time. So it actually can be a dynamic setting. So in this important complex setting, how do we understand how these agentic markets, which are going to happen, how will they evolve? How do we make sure that they're healthy? And how do we make sure that they're adding welfare for the different parties involved, especially the customers? And because this setting is complex, it is important to develop empirical ways to test this out. And this is where Magentic Marketplace, this is a new environment that we built to answer these questions that we built. What this environment lets us do is it lets us systematically and safely simulate these two-sided agentic markets, including the complete life cycle in them, from search to communication between these multiple agents, and even transactions. So it's a complete end-to-end life cycle. And one of the challenges in building an environment like this is to really define the rules of conduct or the rules of participating in this environment. And this is the action space that this environment enables. We call this in our project the market protocol. And there are just so many market protocols that are possible, and there are just so many market designs that are possible. But to start with, we came up with a very simple market protocol that helps us answer some of the initial questions we were interested in. So the market protocol that we came up with has three actions. The first of them is search, of course. This lets the agents discover these businesses. And then another action is to send messages. So this, for instance, lets this agent inquire all these businesses possibly in parallel. And then we have another action like receive messages, which really closes the loop and lets these agents talk to each other. The messages themselves can be typed, so they could be simple text messages. These are useful for initial inquiries and general questions. They could be orders. These are structured orders of JSON objects, because we don't want hallucinations here. And then finally, they could be payment messages. So these are again structured messages, possibly with a pre-approval from the user, where the users can close the transaction. So now we can use this simple setup to answer a lot of questions. So for instance, we can ask, what is the welfare that these agents are able to create for the customers? And how does that welfare compare to some simple baselines that could be participating in this market? We can also ask things like, what is the effect of manipulation and biases in this setting? So for instance, we could ask, what is the revenue a seller would make if they were honest versus they were manipulating, possibly using system injection prompts or attacks? And our initial experiment actually showed that you can earn more revenue So in a healthy marketplace, it's something that you would want to overcome. You can also ask things like, are there any biases that these agents have? And one of the interesting biases that we saw was that when these sellers are all competitive, they're selling the same thing, they get a significant advantage from being the fastest one, even though these agents have received offers from all the other agents. We can also understand the effect of, let's say, search algorithms or the discovery algorithms on the welfare. So for instance, you can change the search algorithm, you can change the bandwidth of the search results. For instance, are you showing 10 results versus 100 results or 200 results? And we actually saw an interesting paradox of choice there, where we were expecting that if you just increase the search results, welfare should only increase because more information is better. And surely computers and agents are better at handling more information. But what we saw was that when we actually, in our setup, increase the number of search results, the welfare actually dropped. So this is something, again, possibly a healthy marketplace could, or better agent design could try to fix. To sum up, the key message of this talk is that before we let these agents operate in markets, we need to test them properly and see how these markets will evolve. And our new open source environment that we build is going to make it very easy to do this. Thank you.